All right, so what I want to show you is how we can interpret some of our equations. Now, this is something that we look at a lot in the grade 10 applied pre-calc course. So for any of you that are intending on going in that direction, this is a great skill to have. Otherwise, if you're not going that direction, it's still a really useful tool, a really useful technique to be aware of or be aware that you can do. And that's making your equation look like this. A variable, so in this case m, is equal to everything else. And that variable that goes before the equal sign, that should be the variable that represents your up and down axis, your vertical axis. So in all these situations, that's true. If that wasn't the case, for example, so sometimes, just as an example, you might have an equation like this, and you're like, oh, well, maybe I can work with that. But you realize right away, hey, my vertical axis is m, and right now I don't have m by itself. So you have to do a little bit of algebra to rearrange things. So in this case here, I'm going to get m by itself. I want it to be positive, so I add m to both sides. I'm left with m minus 2d is equal to 3, and I have to add 2d to both sides. And it ends up becoming the same equation that I had before. Just cover the glare up there for a second. Okay, so once you have your equation set up where your vertical axis, that variable is isolated, is by itself, then we can look at our equation. There's going to be two parts to the equation. There's going to be your other variable, and then there's going to be a number by itself. In this example, the number by itself is 3. In this example, the number by itself is 5. And in this example, you don't see it. If you don't see it, the number by itself is 0. And what that number tells you is where one point on your graph is going to be. And it's always going to be that number on your vertical axis. So for A, I need to find a point at 3 on my vertical axis. On this first graph, 3 is over here. There's no line going through that. So I know for a fact that this can't be A. If I look at this example here, it looks like it could be 3. It's about in the right spot. And in my last example, it's above 4, so it can't be that one. So just by looking at that information, I know straight away that one has to be A. Moving on to my next example, m is equal to 4d. Remember, if nothing is written after the second variable, it means that it's a 0. So that means I should have a point at the 0 on one of my graphs. Not true over here. We already know this is A, but also it's not true on A. But it is true over here, so we know straight away this has to be B. Okay, last example. Just by looking at it, I see a plus 5, so I should have a point at plus 5. We take a look, 5 should be greater than 4, and it looks like there's a point there, so it seems to work. That's the method that I like to use when I'm trying to interpret graphs or try to relate an equation to a graph. Partly because that's what they use in the grade 10 applied pre-calc course, so I get exposed to that a lot. Right now, this is the first time you're seeing something like this. If you want to use that method, it's going to be good for you going forwards. If not, you can still do the logic method, solving through and writing equations out. So that's all I got for you today. I'll get some practice up there as soon as I get a chance to do so, and yeah, we'll see how we're doing with that.